it's all about the planets, and as you can see, it's moving by itself at the moment. It's going through our solar system. In the middle, we have the Earth, and you can see the moon at the side, and soon you will see other planets pass by as well. So what we're going to do is we're going to have a little search around our solar system, and then we're going to point to different planets and moons and find out a little bit more. Here comes the Sun, and we have Venus and Mercury. So I also have my pencil. I'm going to be using that too. But first, let's open this out a bit. Here is the Earth. Now if I turn it, you can see South America. Here is North America. Here is India. Here is Africa. We can see Jupiter in the back, and here is the moon. Here is the moon passing by. And there is Saturn in the back. Now, here is Europe, Russia. Here is the United Kingdom and Ireland. Just there. Italy, Spain and Portugal. There is Australia. Antarctica. Okay, so I'm going to move the Earth back into the centre of the screen. And I'm going to click on this little button here, which should give us some information. Okay. General information about the Earth. Earth, also called the world, and less frequently Gaia and Terra in some works of science fiction, is the third planet from the Sun, the densest planet in the solar system, the largest of the solar system's 4 terrestrial planets, and the only astronomical object known to accommodate life. The earliest life on Earth arose at least 3.5 billion years ago. Earth's biodiversity has expanded continually except when interrupted by mass extinctions, although scholars estimate that over 99% of all species of life, over 5 billion, that ever lived on Earth are extinct. There are still an estimated 10 to 14 million extant species, survival. Earth's human population is divided among about 200 sovereign states which interact through diplomacy, conflict, travel, trade and communication media. Okay, so we're going to go back and we are going to check out another celestial object. We're going to check out the moon. There it is. The moon, Latin Luna, is the Earth's only natural satellite. Although not the largest natural satellite in the solar system, it is among the satellites of major planets the largest relative to the size of the object it orbits. Its primary, and after Jupiter's satellite, Io, is the second most dense satellite among those whose densities are known. The moon is in synchronous rotation with Earth, always showing the same face, with its near side marked by dark volcanic maria that fill between the bright ancient crustal highlands and the prominent impact craters. It is the most luminous object in the sky after the sun. Although it appears a very bright white, its surface is actually dark, with a reflectance just slightly higher than that of worn asphalt. Its prominence in the sky and its regular cycle of phases have, since ancient times, made the moon an important cultural influence on language, calendars, art and mythology. The moon is thought to have formed nearly 4.5 billion years ago, not long after Earth, although there have been several hypotheses for its origin in the past. The current most widely accepted explanation is that the moon formed from the debris left over after a giant impact between Earth and a Mars-sized body. Okay, so here we can see, if I set it spinning, all the craters. It's really quite beautiful actually. This is the dark side of the moon. Okay, let us find something else. There's little Pluto in the distance. the centre of the solar system. The Sun is the closest star to Earth at a mean distance from our planet of 149.6 million kilometres. That's 92.96 million miles. This distance is known as an astronomical unit, abbreviated AU, and sets the scale for measuring distances all across our solar system. The Sun, a huge sphere of mostly ionised gas, supports life on Earth. The connection and interactions between the Sun and Earth drive the seasons, ocean currents, weather and climate. The Sun formed about 4.567 billion years ago from the gravitational collapse of a region within a large molecular cloud. Most of the matter gathered in the centre, while the rest flattened into an orbiting disk that would become the solar system. The central mass became increasingly hot and dense, eventually initiating thermonuclear fusion in its core. It is thought that almost all stars are formed by this process. How the Sun got its name. The Sun has many names in many cultures. The ancient Greeks called it Helios, and the ancient Romans called it Sol, which was translated into sun in modern English. The International Astronomical Union, IAU, has not decided on a single name for the Sun, or the Moon for that matter, but supports the common practice of using the name of the Sun in any language. Let's send the Sun spinning a little bit. Okay, we will find another planet. Well, this is Mercury, which has just come into shot. So let's check it out. We can see Mercury. Let's find out a bit more about Mercury. It is the closest planet to the Sun and the smallest planet in the solar system. Mercury is an extreme planet, the smallest, the second highest in the solar system, the one with the oldest surface, the one with the largest daily variations in surface temperature, and the least explored. Mercury, like Earth, has a global internal magnetic field. Mars and Venus do not. Less than half of the surface of Mercury has been imaged by a spacecraft. Mercury is one of 4 terrestrial planets in the solar system and is a rocky body, like Earth. Mercury consists of approximately 70% metallic and 30% silicate material. Geologists estimate that Mercury's core occupies about 42% of its volume. For Earth, this proportion is 17%. Research published in 2007 suggests that Mercury has a molten core. Surrounding the core is a 500 to 700 kilometre its mass, density, composition and gravity. There, however, the similarities end. Venus is covered by a thick, rapidly spinning atmosphere, creating a scorched world with temperatures hot enough to melt lead and surface pressure 90 times that of Earth. Venus's atmosphere consists mainly of carbon dioxide with clouds of sulfuric acid droplets. Only trace amounts of water have been detected in the atmosphere. The thick atmosphere traps the sun's heat, resulting in surface temperatures higher than 470 degrees Celsius or 880 degrees Fahrenheit. Probes that have landed on Venus survived only a few hours before being destroyed by the incredible temperatures. Sulfur compounds are abundant in Venus's clouds. The corrosive chemistry and dense moving atmosphere cause significant surface weathering and erosion. How Venus got its name. Venus is named for the ancient Roman goddess of love and beauty. Venus is the Roman counterpart to Aphrodite, the Greek goddess of love and beauty. It is believed Venus was named for the most beautiful of the ancient gods because it shone the brightest of the 5 planets known to ancient astronomers. Other civilizations have named it for their god or goddess of love, war. Okay, let us pull out. Now I can see Mars in the corner there. Let's go towards Mars. Here we go. And here we have some moons as well. Phobos and Deimos. There is the great spot of Mars, the red planet. Okay, let's find out more about Mars. Mars is a rocky body about half the size of Earth. As with the other terrestrial planets, Mercury, Venus and Earth, the surface of Mars has been altered by volcanism, impacts, crustal movement and atmospheric effects such as dust storms. Mars has 2 small moons, Phobos and Deimos, that may be captured asteroids. Potato-shaped, they have too little mass for gravity to make them spherical. Phobos, the innermost moon, is heavily cratered, with deep grooves on its surface. How Mars got its name. Mars was named by the Romans for their god of war because of its red, blood-like colour. Other civilizations also named this planet from this attribute. For example, the Egyptians named it Herdesha, meaning the red one. Okay, let's have a look at Mars's moons. So this is Deimos. It definitely looks like a potato. This is Uranus. Like a creamy, milky looking planet. Let's find out more about Uranus. The first planet found with the aid of a telescope, Uranus, was discovered in 1781 by astronomer William Herschel. The seventh planet from the Sun is so distant that it takes 84 years to complete one orbit. Like Venus, Uranus rotates east to west. Uranus's rotation axis is fitted almost parallel to its orbital plane, so Uranus appears to be rotating on its side. This situation may be the result of a collision with a planet-sized body early in the planet's history, which apparently radically changed Uranus's rotation. Because of Uranus's unusual orientation, the planet experiences extreme variations in sunlight during each 20-year-long season. Uranus is one of the two ice giants of the outer solar system. The other is Neptune. The atmosphere is mostly hydrogen and helium, with a small amount of methane and traces of water and ammonia. Uranus gets its blue-green colour from methane gas in the atmosphere. Sunlight passes through the atmosphere and is reflected back out by Uranus's cloud tops. Methane gas absorbs the red portion of the light, resulting in a blue-green colour. The bulk, 80% or more, of the mass of Uranus is contained in an extended liquid core consisting mostly of icy materials, water, methane and ammonia. How Uranus got its name? William Herschel tried unsuccessfully to name his discovery Georgian Sidus after King George III, but instead the planet was for Uranus, the Greek god of the sky. Okay, so let us check out Jupiter. Now, Jupiter's moons are Ganymede, Callisto, Europa, Io. There's Jupiter's red spot just there. It's quite a beautiful planet, isn't it? It almost looks marbled in this picture. Okay, let's find out more about Jupiter. The most massive planet in our solar system, with 4 large moons and many smaller moons, Jupiter forms a kind of miniature solar system. Jupiter resembles a star in composition. In fact, it had been about 80 times more massive, it would have become a star rather than a planet. The composition of Jupiter's atmosphere is similar to that of the Sun, mostly hydrogen and helium. Deep in the atmosphere, the pressure and temperature increase, compressing the hydrogen gas into a liquid. At depths about a third of the way down, the hydrogen becomes metallic and electrically conducting. In this metallic layer, Jupiter's powerful magnetic field is generated by electrical currents driven by Jupiter's fast rotation. At the centre, the immense pressure may support a solid core of rock about the size of Earth. How Jupiter got its name? The largest and most massive of the planets was named Zeus by the Greeks and Jupiter by the Romans. He was the most important deity in both pantheons. Okay, so let's have a closer look at Jupiter's moons. Here we have Europa. Let's find out more about Europa. Jupiter's icy moon Europa is slightly smaller than the Earth's moon. Like the Earth, Europa is thought to have an iron core, a rocky mantle, and a global subsurface ocean of salty water with an icy crust. Europa orbits Jupiter every 3.5 days and is phase-locked, just like Earth's moon, so that the same side of Europa faces Jupiter at all times. However, because Europa's orbit is eccentric, i.e. an ellipse, not a circle, when it is close to Jupiter, the tide is much higher than when it is far from Jupiter. Thus, tidal forces raise and lower the sea beneath the ice, causing constant motion and likely causing the cracks we see in images of Europa's surface from visiting spacecraft. Okay, let's have a look at another planet. Here is Saturn. Okay, so we've pulled right out now. I'm just gonna set the solar system spinning slightly. So let's have a look. We can see the Sun in the centre. Here is the Earth. Here is Saturn, Neptune, Uranus, Jupiter. Let's take a look at Saturn and its rings, and its moons are Dion and Mimas, Tethys, and another one on that side, Enceladus. Let's find out about Saturn. Saturn is probably the best known and most beautiful planet in the solar system. While its possession of a ring system is not unique, it has a set of rings which are far more extensive and more easily seen than that of any other planet. It is this ring system that makes Saturn so beautiful. Saturn is the second largest planet in the solar system, with a diameter of 120,000 kilometres. It orbits the Sun every 30 years at a distance of about 10 times that of the Earth. The shape of the planet is a markedly oblate spheroid with a polar diameter some 10% smaller than that of the equator. Saturn is the least dense of all the planets, its mean density being only 0.7 times that of water. How Saturn got its name? Saturn is named for the Roman god of agriculture. The Greek equivalent was Kronos, father of Zeus, Jupiter. Other civilizations have given different names to Saturn, which is the farthest planet from Earth that can be observed by the unaided human eye. Okay, so there is Titan. I'm actually going to leave it there, but if you various other things that we can look at, different images and more information. So, thank you so much for joining me. This has been